Today we're going to talk about the discriminant. Okay? This word is discriminant. It's not the other word. That's a bad word. Yes, discriminate. Thank you for saying it out loud. Okay? We're not doing that. We are talking about the discriminant. I would like to honor Miss Rosa Parks, however. Yesterday was the anniversary of her standing up for herself in her race. I'm proud of her. I don't know if I could be as brave as her. Okay? Discriminant is what we are talking about today. Here is what the discriminant is. It's another formula that you get to memorize. Not only is it short, you already know it, don't you? Don't you already know that? How do you already know that? Oh, it's part of the quadratic formula. It's inside, right? It's inside the square root. Now, is the square root part of the discriminant? No, only what's underneath the square root is the discriminant. Okay? So, I don't have to show you how to fill this in. You already know how to do this, right? Okay? So, we need to talk about what this can help us know. Okay? When we did this problem just a minute ago, getting back into the swing of things with quadratic formula, how many solutions did we get? We got 2 solutions, right? When we did this formula just a second ago, how many solutions did we get? That's still 2 solutions, right? 2 plus root 3 and 2 minus root 3. That's still 2 solutions, right? What do you notice about both of these problems? They have the plus or minus, right? That's what gives us our 2 solutions. Does the plus or minus always give us 2 solutions? It does not. Okay? But let's think about this for just a second. In this problem right here, what was our discriminant? That is our discriminant for this problem, right? Just the 121. Not the square root, but just what's in the square root. What do you notice about that number? It's positive. How many solutions did we get for a positive number? Positive number gave us 2 solutions, right? Positive number gives 2. We're going to be even more specific than that. Yes, 2 solutions, but 2 real solutions. What's another possibility? Negative. So what if this number right here, instead of being 121, what if it was negative 121? What would happen if I took the square root of it? What would I get right here? 11i, right? So I'd have 7 plus 11i over 2 and 7 minus 11i over 2. Did I still get 2 solutions? But they were 2 imaginary solutions. I'm proud of you for remembering that. Good job. What's the other possibility? It's either positive, negative, or 0. So what happens if this number is 0? If I have 7 plus 0 over 2 and 7 minus 0 over 2, is it imaginary? What's the square root of 0? 0. So that's like it's not even there. Because if I add 0 or subtract 0, it's still the same thing, right? So I just get 1 solution. But guys, how many solutions am I supposed to get? Okay, so let's talk about that real quick. Can we ever get 1 real and 1 imaginary? Think back to the foldable we made about complex conjugates. Can you ever have a 7i without having a negative 7i? No. You're always going to get imaginary solutions in pairs because of complex conjugates. Okay? Pretend this is a 0 again. 7 plus 0 over 2 is 3.5, right? What's 7 minus 0 over 2? So really, I did get two solutions. They're just the same. So it is 1, because we're not going to write 3.5 twice. That's silly. But we need to remember this is a double root. It's one solution, one real solution, except it's 2 because it's double root. They're the same root. Graphically, what does this look like? What does positive look like? So like that. There's a lot of other things it could look like, but that's just one example. What does negative look like? It doesn't cross the x-axis. It could open up or down. It just doesn't cross the x-axis at all. What about 0? Again, we're only talking about vertical parabolas right now. It doesn't cross, it sits right on it. The vertex is the only point that touches the axis. Does that make sense? It has a solution. The number we talked about a minute ago is 3.5. It's going to be 3.5 twice, but that's only going to touch one place. Physically, the parabola is only going to touch one place. Does that make sense? So what you're going to be asked to do is you're going to be given a quadratic equation, like x squared minus 7x minus 18, like this one we did earlier. Okay? And I'm going to say, what is the discriminant? Well, we kind of already did the math, but you're just going to have to do b squared minus 4ac. So you're going to have to do negative 7 squared minus 4 times 1 times negative 18 to know that it's 121. What does that tell you about the number of solutions there are? 2 real solutions. And then when I say, now solve with the quadratic formula, you're going to write it slightly different. Not a lot different, because it's still the quadratic formula, right? X equals negative b plus or minus the square root of the discriminant, which I already know is 121, all over 2a. Okay? We already did the discriminant right there, so we don't have to write it all out again like we did over here when that's all we were doing. Does that make sense? Okay, shortens up. You're solving the quadratic formula a little bit here. Okay? The other thing I want to address real quick is this. Your calculator. It's great if you use it right. It's great if you don't grow up to be a button pusher. Okay? There's been some people that have done this. They make a fraction and then they say 7 plus the square root of negative 7 squared minus 4 times 1 times negative 18 all over 2. Bam, 9. And then they go get it again, except they change this sign right here to a minus. Bam, negative 2. And that's great, isn't it? That's a nice shortcut. Until we get this one, where we say 4. For the record, I did it the way that I would have done it, not the way we did together. That's fine though, right? Because we still got the same answer together. Plus the square root of negative 4 squared minus 4 times 1 times 1 all over 2. That says 3.73. That's just a decimal. Is that what I want? If you write that on your paper, all I know that you can be is a button pusher, and I don't want that. I want you to recognize that you've got to go back and do the work by yourself. Okay? Have a great day.